Alright, so we are going to do section 1.3, and that is describing quantitative data with numbers. So in this lesson, again, this is just a lesson, nothing you got to worry about. If you like to take notes and write this down, I suggest doing so. We're going to talk about mean, median, and standard deviation. So with that today, I know we talked about that a little bit when we were going over 1.2 as far as dealing with all the data with that. We were talking about medians and means and how they kind of where they sit on data curves and things like that. Well, we're going to do some calculations and get that kind of figured out now and how that's actually played out. So with this, let's go ahead and start out first with trying to calculate the mean and the median for this set of numbers right here. Now these are just random numbers that colleges you're applying to. So we did a random survey and we got these values right here. I believe we got 8 people there, so let's do it that way. So to find the mean, hopefully you guys are pretty understanding with the mean. Alright, and so to find the mean, we would simply take our values 5 plus 4 plus 6 plus 5 plus 3 plus 6 plus 8 and then plus 3, and we're going to take all those values and we're going to divide them by the number that we have, the number of values we have, which we have 8 of them. So if we do that, we can simply do that with a calculator. Any calculator is good. Hopefully you are able to get one, those who are lucky enough to have one. But if not, I understand. So let's see what we got here. Not help. Just trying to move this out of the way a little bit so I can see the numbers again. Alright, so we had, we'll go ahead and make this fraction up top. We're going to say 5 plus 4 plus 6, 5, 3, 6, 8. Oh, I didn't even take the first number, dang it. Alright, so let's get this over here. So call it right there. 5, 5, 4, 6, 5, 3, 6, 8, 3. Okay. And then for our bottom number, we said there was 8 numbers altogether. Okay, so that gives us the number 5. So for a mean, we got a value of 5. Now the median is your middle number, right? So our median is the middle value. And to find that out, the easiest way to do this is to go ahead and arrange these numbers from smallest to largest and then determine where the middle is. So with this, we simply have, I'm just going to list these numbers. We have 3. Well, we have 2 3s here. We have a 4. We have 2 5s. We have 2 6s. And we have the last one is an 8. Okay, so there's our 8 numbers. Well, if we count, we go in here, we have 1, 2, 3, 4. Well, the middle, we don't really have a middle, right? We would need to calculate the middle. In other words, we would need to take, since we have an even number of values, we need to take these middle 2 numbers, the 4th and the 5th number, add them up and divide by 2. Well, in this case, hopefully you'll understand that it's simply going to give us a 5. So with this, our median is going to be a 5. Now, talking about that, if we had an odd numbers, if we only had, in this case, let's say that 8 was gone. If that 8 was gone, and we had 7 numbers, then that 4th number would be the median, which in this case, with these values, would still be a 5. That's how it plays out. If it's odd, you're lucky because you can just pick the middle number. If it's an even amount of numbers, you need to add up and divide by 2 on the middle values. Okay, so we have our mean and median. Now before we go, we talked about range yesterday, and so what would our range be in this case? Hopefully you guys remember that range is going to be taking your largest number minus your smallest. So it's max minus the min, right? In this case, our largest number, we put them in order here, largest number was 8 minus 3. So that gave us 5. So in this case, our mean, median, and range all equaled 5. Kind of worked out pretty good, right? So now the other thing we're going to talk about, since we kind of understand mean, median, and range now a little bit, we want to talk about our standard deviation. So standard deviation. So I'm going to go to another sheet here. We'll clear this off. We're going to talk about standard deviation. Standard deviation, I'll abbreviate it like that. I don't feel like writing it all out, nor do y'all really want to watch or read my scribble. That can also be written as just SD for right now, okay? And for this, sorry, let me see. Trying to get the thing squared away, right? So for our standard deviation, the true equation for that is going to be the square root and sigma, which is meaning sum. So that means sum of our values, the initial value, minus the mean value squared. So you're taking the value, like we would take 5 minus our mean value, which is 5, and square it. And we're doing that with each one of these numbers to add them up. We're going to go through that. But all of this is then divided by n, our sample size, minus 1. Okay? So we know, as we said above, our mean is equal to 5. So we know that our x bar is equal to 5. Now your x with little subscript I, this is meaning your initial value or the values that you have there, okay? So with this, let's do this. Let's list all these numbers out. So let's go ahead and say the values are 5, 4, 6, 5, 3, 6, 8, 3. Okay. Make a little chart here. So we'll say, we'll call this the values. Now in here, we're going to say this is going to be our x initial minus our mean, okay? And then on this last one, we're going to take that value and we're going to square it. So to do this, again, we had 5 minus 5 gets us 0. We had 4 minus 5, which gives us negative 1. We had 6 minus 5, which gives us 1. We have 5 minus 5, which gives us 0. 3 minus 5, which gives us negative 2. 6 minus 5, which gives us 1. 8 minus 5, which gives us 3. And 3 minus 5, which gives us negative 2. Alright, so now we have those values. Now we just need to go ahead and square them all, right? So this will be pretty easy. No reason for a calculator with that. That seems pretty simple. So we should have 0, and negative 1 squared is going to give us a 1. 1 squared is going to give us a 1. 0 squared is 0. Negative 2 squared is going to give us 4. 1 squared is a 1. 3 squared is a 9. And negative 2 squared, like it was, is a 4. So now we have all these values right there. We have all the values that go right here in the sum part for the sigma. However, now we just need to find what that total is. So with this, I'm just going to write our see, I'll put it like this. We'll say our sigma of x initial minus x bar squared equals, and let's add that up. Okay, well, we got 13, 14, 18, 19, 20. So it should give us 20. Alright, so that's the top part. Now that we know the top part is 20, all we got to find is the bottom. We're going to divide by, right? So n, again, is our sample size. So n sample size. Okay, so if you have sample size of 8, so in this case n equals 8, so underneath there, we're going to say 8 minus 1. So, to find our standard deviation, our equation that we would put in the calculator is simply going to be, we found 20 as our top value, divided by 8 minus 1. Or you could just put a 7, but I'm just going to write it out. So again, we're going to take the square root of, I mean to erase that, my bad. Take the square root of 20 divided by 7. Okay, and let's get the calculator right down here. So we're going to take the square root of the fraction 20. Why is it not taking that first number I'm hitting? 20 divided by 7. Okay, so we're going to go, I'm just going to round it to 2 decimal places right there. So we're going to say 1.69. So 1.69. So in reality, what that's telling you is the amount of college out of that group right there, the amount of colleges that people were applying to varies from the mean by 1.69 colleges, okay, from each standard deviation. So now that you guys have figured out as far as your mean, your median, and your standard deviation, and also having your range, you guys remember how to do the range as far as your max minus your min, everything should be all right with that. So let's go ahead and let's say this. With that, with those values, we'll say our standard deviation 1.69, our mean was 5, our median was 5, Our sample size was 8. Our range was 5. But what happens if another value is thrown in there? What if we wanted to include mine? Let's say I throw in and I want to do 20 colleges. So now let's say I throw up here 20. So what changes? And how is that going to change things? So if I throw 20 up there, it's going to change a few things, right? What's the first thing that we're going to change? Is it going to be just a standard deviation? Is the mean going to change? Is the median going to change? Is the range going to change? Hopefully you'll see quite a few things change, right? So with this, now our sample size goes up to 9. And with this, let's put these in order, see if we can find the median. So you go ahead at 3, 4, couple 5s, couple 6s, and an 8, and then we had our 20. Well, now we have 9, so we have an odd number, so therefore we should be able to find just the 5th value that would calculate as our median. So if we go 1, 2, 3, 4, 5. So our median is still this 5 right there. So the median didn't change. But what about this mean? That's going to change, right? Because you can add all those up and divide by 9. Well, if we do that, let's see here. Let's take our calculator. Pretty sure it's still left there. So if we do that, let's take this. Let's go ahead and add 20. And then we'll, instead of 8, we'll make that a 9. And so now our mean jumps up to 6.67. So now our mean is 6.67. The range is going to change. Alright, so now we're taking 20 minus 3, which gives us 17. A standard deviation. So with that, the one extra part we're going to have in this, for standard deviation, since our mean and everything else has changed, we've got to change all those values, right? Well, let's just go ahead and do this. Let's see what it does here. Hang on one second. Okay, so let's get the calculator and make this a little bit easier since a lot of figures have changed. I don't feel like writing out all that stuff to do it again. Especially if you have a calculator like this or an 84, 83. Some calculator can do this awesome scientific work here. So on this part, for the TI Inspire, I'm going to go ahead and open up a spreadsheet. Now up here at the top, I'm going to go ahead and label this column. Label it just, let's see if I just have college. Well, let me write all that out. There we go, college. We'll name it college. Alright, so then I'm going to put all of our data values that we had. So we had 5, 4, 6, alright, so, and again, we knew we had 9 altogether, so it matched up with 9, so it should be good. Now, next thing you gotta do is make sure in a blank square, if you have an Inspire and able to do this, and then you want to hit Menu, Statistics, Stat Calculations, and it should be one variable Statistics, and just click OK. On this, for the X list, we're going to label it what we call this for as college, and then the results are going to go in C, which is fine. So all I got to do, okay. Now this gives us everything that we need to know. All right, on here with this, the SX right here, this value is classified as your standard deviation. All right, so the standard deviation now went to 5.24. So our standard deviation is now 5.24. So that changed quite a bit, right? Quite a bit. Let's see if we got everything else right. We can also double check this. It gives us a little bit more information. Let's see. Alright, so we scroll right over the top here. This gives us our mean. The X bar is 6.6666, which we already determined, so we call it 6.67. So I knew that. Our sample size was a 9. And then we'll go into these other figures down here, the 5-number summary. We'll go into that later. But the big thing you need to worry about here is you got your mean value of 6.66, or 6.67, sorry. Your standard deviation of 5.24. And of course you can always double check to make sure the sample size, your N value, is 9, which we knew is what it was. So a lot of times you'll get a question like this, they'll throw in another number like that, and they want you to describe how did it change. Well, then you've got to say what happened, which you can visually see, but all you have to do is write it out. And instead of y'all reading my chicken scratch, I'm going to type it, make it a little bit more legible. So let's see what we got here. Alright. So if it'll let me type here. Okay. So let's see. We should say the new mean and standard deviation increased from the original values. The median stayed the same. And let's go with this. So if you were to see these values and you have arranged, initially from 3 to 8, what would you label 20 as? Would you consider that being in the group of numbers, or would you consider that an outlier? Well, hopefully looking at it, you consider that an outlier because it's way far away. If you did a dot plot, you'd have your values in the 3 to 8 range, and then that value way out at 20. So with this, the reason those changed, so you can say this is because the outlier greatly increased the total, which affects the mean and standard deviation. But what didn't it affect? It did not affect the median, but did not affect the median. Alright, so I'll make it a little bit bigger in case I need to see it. Just highlight it real quick. So again, you would simply write out, you would say that the new mean and standard deviation increased, because we saw that right here. We went from 1.69 to 5.24 standard deviation, and the mean went from 5 to 6.67. Then you talk about the median. Well, the median stayed the same in this case. And then you need to tell why that happened. Why did this change occur? Well, it occurred because you had an outlier that greatly affected the increase, right? It caused an increase in the total, which affects the mean and the standard deviation. And in this case, it did not affect the median. Alright, so hopefully that helps you all understand the mean and median and standard deviation a little bit better, and I'll see you next time.